Hey guys, today we're going to start into chapter 9. We're going to look at chapter 9.1 and we're going to be learning all about graphing quadratic functions. So the point behind why we learn how to factor, talked a little bit about that in class. I hate it when that won't work. Let's do it a little lower, but there we go. Okay. So first off, quadratic function, we've talked about quadratic equations, and they have a couple of criteria. Quadratic functions. So remember, functions and equations are pretty much interchangeable. It has a degree, so that's exponent we're talking about, of 2. That's going to be the largest exponent. And a non-linear graph. Linear, I think I forgot a letter. Let's try that again. Linear graph. Okay, and we're going to talk about that graph, which is called a parabola, in just a little bit. And written in standard form. We talked about that in another lesson. And that looks like this. Ax squared, well actually let's do it this way. F at x is equal to ax squared plus bx plus c. We talked about how those letters represent the quadratic coefficient is a, the b is the linear coefficient, and c is the constant. Now they will come into play. Oh, I do have a stipulation. The quadratic coefficient cannot equal 0. If it was 0, it would take out that term, and it would not be a quadratic function. It would be a linear function. Okay, so what is that graph called? That graph is called a parabola. A lot of people want to say parabola, but that's not how you say it. It's a parabola. So parabola is the graph of a quadratic function. Okay. Now, what's interesting about this graph, it has symmetry. So it's symmetric, and remember, symmetry means that it has a line, kind of invisible line, that if you drew it through the middle of the graph, you'd have two pieces that would fold up and match each other exactly, okay? So it's symmetric about a line. Now this line is not part of the graph, it's just we draw it in to show the line of symmetry down the center of the parabola. It's got a very special role, so it has a name. It's called the axis of symmetry. Now we're actually going to be able to figure out how to do that. Now, something interesting about this axis of symmetry, so let's put it over here, we'll do it by itself. It passes through an extraordinarily important part of the graph, and that axis of symmetry intersects the parabola. At its vertex. At its vertex. Okay, so the vertex is either going to be the lowest point of the parabola or the highest point of the parabola. So I'm going to draw you some pictures so you can see that vertex in action. So we're going to draw a parabola, and this one's going to be kind of like this. This is your vertex. It would be right here. and it's through that vertex that the line of symmetry goes through. And if you fold along that, on that line of axis symmetry, sorry, the two sides of the parabola would meet each other. Okay. So when the vertex is at the bottom like this, it is considered a minimum, and it's the lowest y value of the parabola. Okay. Oh, I did want to mention that we talked about this in class. Where the parabola crosses the x-axis, that's called the solution. It's also called the intercepts. Let's see, solutions, intercepts, and roots. Okay, and you'll spend a lot of different math years working on that. Now, we can also have a parabola that faces a different direction. That would be a downward facing parabola, and we're going to talk a little bit later about when does that happen. So let's do this parabola. Okay, and so its vertex would be the highest point of the graph. So that's your maximum because it's at the highest point. And this would be the highest y value. Oops. Highest y value. So if you're asked to find domain and range, you could use that information to help you with that. And notice this time that this is the only solution, intercept, or root. It only touches the x-axis at one point. Okay, now let's go back and talk about axis of symmetry. I mentioned that you will be able to figure out what it is using a formula. If I didn't say all of that, now you just heard it. Okay, so this is what we're going to do. To figure out the axis of symmetry, it is going to be a vertical line, so it's going to be x equals, and then it's negative b over 2a. Okay, now you might say, where's the b and the a coming from? I'm going to draw a little line connecting to them. Remember these guys? Whoop, and whoop. It's coming right from the equation written in standard form, okay? Now, the other amazing thing about the axis of symmetry, this is the x-coordinate of the vertex. Oh yeah, baby. Awesome, right? Now, the vertex is going to, look like a normal pair of coordinates, voila. And we have the axis of symmetry is going to be this part. So how do you figure out the y-coordinate? Well, you got to do some math. So the y-coordinate of the vertex we substitute the x-coordinate, which we just got from the axis of symmetry, into the equation, so that's your quadratic function equation, and solve for y. Oops, sorry, and solve for the y-coordinate. Okay, so that's going to be interesting. Now I've run myself out of room on this slide. You're still on your first page. I'm going to go ahead to the next slide. So, when we are graphing, we need 5 points. Why? Because we need to find the bottom of or top of our and we'll find the vertex, let's just say that, and then we need to build out our parabola to the left and to the right. So we are going to use 5 points, and we're going to be very systematic on how we do it, and then that way the parabola will build neatly. Let's see, you need 5 points. And evenly from left to right. You need 5 points. So I'm going to tell you how to do this. So we're going to create a T-chart. Now, often in the T-chart, we'll need to do some work, but you can do that off to the side. So here's what you're going to do first and foremost. You're going to put the vertex in the center. So the coordinates for the vertex are going to be in the center of the graph. Okay, so what I'm going to do is I'm going to use the x coordinate of the vertex to help me get my other coordinates. What am I going to do? Well, I'm going to add 1 and then add 2. Now to keep the balance, underneath, I'm going to subtract 1 and I'm going to subtract 2. Now here's where magic occurs. Are you ready for this? Here we go. When I substitute in x, the coordinate, x coordinate of the vertex, and I add 1 to that x coordinate, and I substitute that into the equation, I get a y value that's going to be different from the vertex's y. But here's what's really strange. We're using the idea of symmetry. So on the x minus 1 coordinate that we're going to plug in for x, we also get the identical y. If you're not, you're doing something wrong. Just saying. Okay? Then, when I go to x plus 2, I get a different y coordinate. But when I do x minus 2, I also get the same y coordinate. So, here's what we're going to do. When we practice this, you're going to see this come into play. Okay? So, if you are asked to figure out domain and range, this has been so typical with all our graphs, is that the domain is going to be all real numbers. Your parabola is going to continue to grow and it's going to expand. You don't see it, right? Because we're only looking at a small portion of it. Now, range is a little bit more interesting. Oops. It depends upon 2 things. First, it's going to use the number, that's the y coordinate of the vertex. So remember when we were doing range, we'd say something like y is greater than 2. Okay, so that's as low as the graph went, and then it went up from there. Okay, or we'd say y is less than 3, so 3 is the most it was, and then it went down from there. It's the same sort of idea. Okay, so the y coordinate of the vertex is the starting point. For the range. Okay, and so I'm going to give you little pictures here. X-axis, y-axis. I'm going to do 2 parabolas on it. So on this guy, your parabola has a vertex that's a minimum. So the inequality we'll use will be greater than or equal to, because it's the smallest number, and then it's y is going upward. And if we have a downward facing parabola, then the vertex is up here, so that's going to be a maximum, because it's the largest possible number. So then it's y's that are getting smaller. So we would use less than or equal to. Now the reason why it's or equal to is because it starts at the vertex, which is a physical point on the graph. All right, I'm going to go to the next page just because I want to have plenty of room to show this example, but you guys are probably might still be on the same first page, or you might be on your now second page, whereas I'm on my third. Okay, so let's do an example. And it's going to say use the table of values, or use a table, sorry, of values to graph y equals 3x squared plus 6x minus 4. Okay, and then state domain and range. Okay, so steps. What do we do? First, we're going to list from our equation the a, the b, and the c values. You might say, well, why would we list the c value? Okay, I'm just going to tell you right now, get in the habit, all right? Because it's going to be important down the line. So for this one, the a goes with the quadratic coefficient, so it's 3. The b goes with the linear, or it's a linear coefficient, that's the 6. And c is the -4. Okay? Next, we're going to determine the axis of symmetry. So, axis of symmetry. Try that again. The axis of symmetry is a formula. X equals -b over 2a. I'm going to show you a couple lessons down the line where that baby comes from. Okay? So, we're going to start substituting the values from above in there. So we get x equals, and we're going to have the negative of c. So I'm going to put, all of this would be the same color. And now I'm going to substitute my values in. And b value is 6. So the negative of b over 2 times a. And the a happens to be 3. So this gives me x equals -6 over 6, or x equals -1. Okay? So this is important because this is half of the vertex. So that's your next step, is determine the vertex. So we are going to take our equation, and we already know that the x-coordinate of the vertex is -1, because we just calculated that. And now I'm going to go over to the side here, and I'm going to be doing the math on the formula here. So I'm going to take y equals, and I'm going to put 3, and then every time I see x, I'm going to put in a -1. And then plus 6 times x, and then -4. So we get y equals, oh sorry, I messed up. That's first one squared. So -1 squared is a +1. +1 times 3 is 3. 6 times a -1 is -6, and then there's a -4. So we have 6 take away, or 3 take away 6 is -3. -3 take away 4 is -7. So we're going to go ahead and plop in -7. So my vertex is sitting at -1, -7. Now that I have that, I can go ahead and create my table of values. So create the t-chart. So I have x, y, and I'm going to put my vertex in the center. So we're going to say it's -1, -7. So remember what I said. We're going to take that vertex. Actually, let me get rid of this line. We're going to get rid of that, or take that -1, and we're going to add 1 to it. So we're going to, remember, we're going to do x plus 1. And we're going to do x minus 1. Okay? So we do x plus 1. So -1 plus 1, and that takes us to 0. -1 take away 1, that's going to take us to -2. Now, I'm going to calculate this answer. So y equals 3 times 0 squared plus 6 times 0 minus 4. So I get 0 plus 0 minus 4 equals -4. Now I'm going to prove to you that this actually does work. So I'm going to have y equals 3 times -2 squared plus 6 times -2 minus 4. That's going to give me -2 squared is 4. 4 times 3 is 12. And then we've got 6 times -2 is -12, and then minus 4. I don't know why I put that parentheses there. These cancel out, leaving me with -4. Matchy, matchy, right? Let's see if I can remove this guy. I don't know why I put that in there. Okay, better. Then I'm going to pick the numbers that are x plus 2 and x minus 2 away from my vertex, okay, because my vertex is x. And let's see what we get. So we're going to get -1 plus 2 is 1. -1 minus 2 is -3. So if you notice the way I'm doing it, my numbers in my x's should be 1 apart at all times. So I'm going to put my numbers in here, and we're going to get y equals 3 times 1 squared plus 6 times 1 minus 4. That's going to give me 1 squared is 1 times 3 is 3 plus 6 minus 4. And I have 9 take away 4 equals a positive 5. So notice what's happening to your y values. In the middle, at the vertex, is a -7. But as I go up my parabola, my numbers start getting larger, -4. And then I go up to a positive 5. All right, and then again, I'm going to prove to you that it works on this guy. So I have 3 to -3 squared plus 6 times -3 minus 4 equals, so -3 squared is 9 times 3 is 27. And then we have, let's see, -18 and then minus 4. So let's see, that's going to give me a -9 take away 4. That's going to give me a positive 5. So it does work. Okay, so now we're going to graph. I think I'm going to pull in some graph paper just to make it easier. All right, so we're going to graph. Let's see, I need to go to 5 up and -7 down. So we'll start with kind of counting that way. And then this would be my x-axis. 2, 3, 4, 6. So I'm going to shorten this a little bit. Add in my arrow caps. Label x and y. And then I'm going to put my tick marks over here. So there's -2, there's +2, and let's get all our numbers in. I like to do every other, evens only, And then I'm going to start graphing my ordered pairs. Now I'm just going to use one solid color for all of them. So we go 1, 5, 0, -4, -1, -7, -2, -4. Ooh, this is a skinny sucker. And then we have -3, 5. So when we draw this, we're going to be kind of sketching it. We're going to have a point where it curves back up again. Okay. And you can kind of visualize. There's your axis of symmetry. And you can see the two sides look pretty even, not terribly bad. So then I have to do my domain and range, and we already said that domain is going to be all real numbers. Now range is determined by the y-coordinate. Now my parabola is facing upward, so that says our y values are going to be greater than or equal to. So actually, let me move that down a little bit. We're going to use set builder notation where we have the y values such that y is greater than or equal to -7. Okay? Okay, one more page over, one short little problem to do. The directions are actually longer than the problem. It's going to ask us from a graph, we're going to find the vertex, the equation of the axis of symmetry, and the y-intercept of the graph. Now I'm going to pause this and do the graph, get it right, and then come back. Okay, so let's see what we can figure out. So first thing we're going to do is find the vertex. So vertex is pretty simple. We find the highest or lowest point. It's right here. So that's going to be 2 on the x-axis over to 3 on the y-axis. Now, the axis of symmetry is going to fall. It's going to be this vertical line. So I'm going to color it in slightly differently. That passes through the vertex. So it's a vertical line. So the axis of symmetry is going, I don't even need to calculate it when I see this picture. It's going to be x equals, and it's whatever it passes through on the x-axis, which is at 2. Now notice, it's the x-coordinate of your vertex. Okay, now the y-intercept, where does it cross the y-axis, would be right here, which is at 0, -1. Now, we're going to do more in class when we meet again on Monday and Tuesday, and we'll add to these notes. All right, good luck with this, guys. Bye now.